Hi, students. I wanted to show you this chapter, Module 5, Weathering, Erosion, and Soil. And I love this picture. Sorry, I stalled for a second. If any of you guys know where that is, it is gorgeous. It's like I want to swim in that, and I don't want to swim in it because I can see that it is pure ice melt. Okay, so what do you need to know about weathering? So weathering is the process that things are basically just broken down and changed. However, in the first type of weathering that we're going to talk about, because we have two, it's mechanical and we have chemical. So in mechanical weathering, you actually don't change what's the composition of what's there, just the physical form or shape. So mechanical weathering maybe busts something up, but if you tested the chemistry, it's still the same thing. So one of the biggest uh, effects on mechanical weathering is actually the process of freezing and thawing. So in areas where it gets warm and then it has a wet frozen time, and then it warms up, and then there's a wet frozen time. It makes it so that water can get down in between like rocks and soil, and it goes down, it expands by 9% when it's frozen, and it cracks it all up. Then it gets warm, and then it rains and more water comes down, and it does it again until it's really cracked up. This is called frost wedging. So really cold areas, especially, this can happen. It mentions potholes in the road. This is a good reason that happens. Other damage can also happen, but really a lot of it is freezing and thawing. So the effect of pressure is very similar. Now here's a cool tree that has grown all through this rock and is able to crack it up. Now that has always amazed me over time, that a tiny little root can just wedge its way in there and in there and in there and grow and put enough pressure that it just breaks rock. I can't even really break a lot of big rocks like that, but this tree that started off a lot smaller can, and they can uplift your house, and they can break walls, and they can uplift sidewalks and do a ton of damage. But I'm not speaking out against the trees, but they are actually very powerful just using that pressure. So there's other things that can put pressure on things, just like animals, humans being on things, damage that way can cause some mechanical weathering. Also, geologic forces like uplift and two different plates hitting each other, and geologic plates and pushing on each other is that same pressure. This is a picture of, do any of you guys know? It is Yosemite, a very famous rock, I guess. It's one big giant rock, and it is actually exfoliating. Some people use like face wash and things that's exfoliating, has little like sandy gritty things in it, and that actually takes off dead layers of skin. To take off a dead layer of skin is called exfoliating, and it's the same thing on the rock. Slowly this massive rock is exfoliating chunks of itself as it breaks apart. In your lifetime, Half Dome will always be there. There was just a cool documentary about a guy climbing Half Dome. If you didn't see it, wow, that guy was intense. Okay, so in chemical weathering is when there's actual chemicals that break something down over time, and it can be, water is a chemical, believe it or not. Even though you drink it, it's a chemical, right? It's made up of hydrogen and oxygen. Then oxygen is a chemical, carbon dioxide, and acid rain, acid precipitation. We will talk about each of those. So there's a few things that break down by chemical weathering a little bit faster. Some of those are like made of calcite, like um, marble or limestone. I actually want to, well, I'll show you that in a second. But then there's other rocks that are slower, like granite barely erodes compared to limestone or marble. So some rocks are faster, some are slower. Water actually does slowly dissolve things over time. You wouldn't think it, but it does. Um, and there's some things that it mentions in there, but oxygen can too, and it's called oxidation. If, like rust, can iron can get rusty from oxidation and be broken down. Then there's carbon dioxide. This is acid rain. So, it says around the world would have been damaged by acid rain. I don't know if I don't know if that picture is specifically about acid rain, but acid rain can basically break down things because rain, so all of the pollutants that go up in the air, and pollutants, even the carbon dioxide that you breathe out. So, what are you going to do about that? But, anyways, so some of it we can help, some of it we can't really help. But all those pollutants in the air, the same, like what goes up must come down. That's basically true in the case of pollutants, because then when it rains, that water gathers, and all that, CO2 and sulfur dioxide and everything else just ends up making things like carbonic acid, and it falls down. So all of the rain that does hit you in Southern California is acid rain. Now, it's not going to melt your face off, and some of you guys have, gone out and drank some while it's coming down, and you've been just fine. And that's because it's not a very strong acid. It's is acidic somewhere between coffee with heavy creamer in it, which I don't drink coffee, but that's basically the same acidity level. It's about a 5.6. So it's not going to melt your face off. But when you look at this lion, over time, he has slowly been eroded because of chemical weathering with acid rain. Okay, moving on, and I'll try to speed it up here. What also affects the rate of chemical weathering is where you are on the planet. The red zones, like I went here to Guatemala right here, and this summer, and I got to work with the people, but I also got to work in a place called Tikal. Or actually, I didn't work there. I got to visit there. It was just a visit, but I went to Tikal, and they are right here. And here are some of the big like temples, and you can see that they're highly weathered, and they're really weathered because it basically is exposed to acid and heat and plenty of rain. So the next one that I want to show you, oh, here's just another one with like my daughters. Here also, it's covered with soil. These were actually like structures the people had built thousands of years ago, and they're completely covered in soil, and they haven't even been unearthed yet by teams. Let me find this one. That's not what I want to show you yet. Okay. Then though, I also went to the Middle East. Okay. And I did drought research there in Israel and Jordan and Turkey. And this is, I apologize, this is Israel, and it's made of limestone, which normally would, and so was Tikal. Tikal was also limestone. And these structures are actually much older than these structures, probably. And yet, people still fully live in these cities. This isn't the best picture to show that, but there's street vendors and businesses and people living in it. And yet, this is older. But because it's in a very dry area, there's not much acid rain, and it's very dry. So there's not much moisture, there's not freezing, so it's kind of protected for a long time. Okay, so I want to show you this picture. This was a needle called Cleopatra's needle or something that they brought over to the United States when 150 years ago about. And then they put it in New York instead of having it in its very dry Middle East. And because it was in a very wet, freezing, humid area, it has totally deteriorated. Although this is what one looks like that they left in Egypt. So what Egypt did to it and what New York did to it. So weather makes a huge difference. The last quick little thing I'm going to show you is here on surface area. If you break something into smaller pieces, it dissolves even faster, which is why when I go camping, I always take the block ice, the big block ice, because it lasts like 5 days in my cooler. But if I take the tiny little chipped ice, it's gone in like a day, day and a half, right? Or I don't know. I can't. There's other examples that I thought of that. But if you guys have ever tried to dissolve something like bath bomb or something like that that's fizzy and in the water, if you smash it up, it's going to be gone faster, right? So blocks of things take longer. So that's all I wanted to go over with you in this section. And I hope you guys have a great day.